Okay, so I have the book here. You said 342. 342, problem 22. Yes, so we are given k of x equals 1 over the square root of x, or x to negative 1/2 if I need it. We'll see. Find the linearization of, so this, which we know, it's f prime of a plus f prime of a, f of a plus f prime of a times x minus a. And they are telling us that a is 4. Is this the problem?
Yes.
Okay, perfect. So all I have to do is just find the derivative. So of course I used f instead of k, so sorry about that. So I have to find f k prime of 4, which is first let's find f prime of x. I'm going to change this so I don't use two different things. So negative 1/2 x to negative 1/2 minus 1. So then now f prime of 4 will be negative 1/2, the square root first. The square root of 4 is 2. 2 to negative 3 is 1 over 8. So this is negative 1 over 16. And f of 4 will be 1 over 2. So f of 4 is 1/2. So now the linearization, all I have to do is plug in those numbers. This is 1/2 plus this, which is negative 1 over 16, and this, which is x minus 4. I have to distribute, combine like terms, simplify as much as possible. So I have L of x equals 1/2 minus 1 over 16x, but plus 1 over 4. 1 over 16 times 4 over 1, simplify, 1/4. I have to add these two, and we know 1/2 plus a quarter is 3/4. So L of x, negative 1 over 16x plus 3/4. This is the linearization. Was this clear, or was this a problem?
Yeah, I was just worried about like the distribution of parentheses because in the end, I think I got the answer right, but the equation just confused me. But this cleared it up.
Okay, perfect. So now, do I need to do anything else, or is this good enough, or
No, that's good. Thank you.
do I need anything else?
Well, I think the equation continues with like approximating something, but I'm pretty sure I got that down.
So in the approximation, so it says unit is it to approximate 1 over the square root of 3. So you have x equals 4 and dx equals negative 1. So what I would also ask, I think this is even more in line with what we are discussing, that just using the linearization. Remember, we have f of x plus dx is approximately f of x plus f prime of x dx, which is the same thing, and dx. So dx in our example is negative 1. F of 1/4, f of 1/4 is 1/2. And f prime of 1/4 is the same thing we just got, negative 1 over 16. And this is times negative 1. That's the easiest thing to do. Or it's the same thing if you put in 3 here, as they wanted us to do. So it's the same thing. Or this, whichever you prefer. So 1 over the square root of 3 will be approximately this, which is, now I can use the equal symbol, 1/2 plus 1 over 16. So this is 9/16 because I need to multiply this by 8. So then they are asking us, I'm going to share my screen and go to the graphing calculator. They're asking us to check. So we want to check. So I will check 9 over 16. And I will check 1 over the square root of 3. Then this was part B. Part C, we just did. What is the difference between the approximation and the actual value? So I just have to determine the difference. So this is the actual, so the difference, or delta y. This is what it is, delta y. 0.57735, I don't know how many digits they want, minus 0.5625. And we determine that. Very good question. Anything else?
Thank you.
Thank you.
Question.
Yes, I'm ready.
So when it does do that for like the question that you were just on, we can just input the 3 for.
Yes. Yes, I just wanted to review
X
this because this is very important.
Okay.
But yes, you can just input 3 here, and this is what you get. I just
Do we
wanted
have to
to.
use that formula, or do we?
I may ask you this formula. That's why I put it here so you can see it's the same thing. Okay? As if you put in here positive 3, and you still get negative 1. Right? So you get 1/2 minus 1 over 16, and 3 minus 4 is negative 1. Or you can put it in here. It's the same thing. Negative 3 over 16 plus 3 over 4. Same thing.
Where did you derive that formula from?
This one,
Yeah.
I'm reaching my recycling bin. Delta y, approximately dy. Delta y approximately dy. Delta y f of x plus dx minus f of x. dy f prime of x dx. And we move f of x to the other side. I always hope that my students will watch the videos. If you watch at least one more time, this will be carved in stone.
Thank you.
Thank you. Very good. Good question. Anything else? Other questions for me? Okay, we are trying to accomplish 2 things tonight. One is something called implicit differentiation. So this is section 3.8, implicit differentiation.
Nice read.
Yes, I'm ready.
The test is next Tuesday, right?
Yes.
All right then.
So implicit differentiation versus direct. So what is the difference between implicit and direct? Direct means I have the function. So here is an example. Y squared. I don't want y squared. That would be the example for implicit. Y minus 3x squared plus 4 equals 10. I can solve. Y equals 3x squared and plus 6. I can find y prime or dy over dx, and I say it's 6x. This is direct. I was given the function, or it was easy to solve for the function, and then I found that its derivative. So another example is implicit, when I cannot solve for the function, or the function is not given to me directly. It was given through an equation, but it's still direct. Now here's another example for you. let's say, this is my page 3, yes. Y cubed plus 2x y squared minus 4x to the third equals 0. The question is still asking us to find dy over dx. But I cannot solve this for y. So I will be able to solve by implicit differentiation, because the function is not given to me. I cannot solve, it's y cubed and then y squared. I cannot solve this for y. So can I still find an expression for dy over dx? Yes. What does this represent? The rate of change of this function with respect to x. Can I find an expression for it? Yes. So I am going to apply an operator. By applying an operator, I mean, if I have, let's say, x squared equals 4, I'm applying this operator to both sides. If I have the square root of x equals 2, I'm applying this operator to both sides in order to solve. Anything that I do to both sides is an operator. Well, I will apply this operator to both sides to find this. Exactly like applying this here or this here, as long as I apply it to both sides. So now I will differentiate. Before I start, I recommend put a dot under the function. So you don't differentiate as if it's a variable. It's not a variable. It's a function. How do I know? Because the problem is asking me to find dy over dx. This notation states y is a function of x. That's what it tells me. Y is a function of x. Treat it as such. So then, when I differentiate a function to the third power, I get 3 y to the second power times the inner function prime. Three y squared times the inner function prime plus 2. This is function 1 and this is function 2. I have to use the product rule. Okay. The first function prime is 1 times the second function plus the first function times the second function prime, exactly like here. 2 times y to 2 minus 1 times dy over dx. Minus, this is no function, so I have minus 12x squared. I differentiate 0, I get 0. Let's see if we understand these steps. And then we'll choose problems from the book in a minute. Any questions? We haven't finished. So now, remember what we are after. I am after this and this. This is my variable now. From this point on, it's just algebra. But I can't do anything before I distribute here. 2 to this and 2 to this. So let's do that first. So 3y squared dy over dx plus 2 times y squared plus 2 times 2 times x times y dy over dx. I can already move this to the other side, but I will not do it right now. These are the two terms that contain the variable. I cannot combine like terms, but I can pull out dy over dx. This term has to move to the other side, so does this one. So I have 12x squared, but minus 2y squared. And here I have 3y squared plus 4xy. Finished? Almost. Almost. I'm after this. I will divide this by this, because this is the number in front of the variable. It's multiplied. So I have to divide both sides by this quantity. And that's done. Any questions? Anyone, please? So, dy over dx, this 12x squared minus 2y squared over this, 3y squared plus 4xy. Done. Now you could say, wait a minute, wait a minute, wait a minute. What are you talking about? This expression still has y in it, which you don't have because you can't solve the equation. True, but I still have an expression for the rate of change of this function with respect to x. It's a huge and important step. But yes, I cannot eliminate y from here. So now if you tell me evaluate this when x is and y is, I will be able to give you a number. So, when x is 0, y will be 0. So let's see if I can solve quickly when y is 1, to give you the example. I just made it up. So let's say when y is 1, I have 1 plus 2x minus 4x cubed equals 0. Now I will have to solve that equation. So we'll find another example, because it will take a while for me to find the x value. It doesn't matter. We'll look at something else. So if I say x is this and y is this, I will be able to get a number, whatever the number is. I will plug in x, but I can't just make it up. It has to be a point that verifies the original equation. I cannot just say 5 and 3. No, 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 no. I can't do that. So it has to be a point that if x is 1, then I have here the value of y for that one, or vice versa, or any point. But we will illustrate this in a moment with, no, not with that, not with my email. That will not work. Where is my book? My book disappeared. No, it didn't disappear. It's right here. So this is in 3.8. So we want section 3.8. And we want page 359. Let's see. Page 359. We are not going to look at logarithmic differentiation. We are happy with implicit differentiation. If you do find an example, I think you will not, but if you do, let me know right away. In a problem in MyLab Math.